very many videos where you will get to watch me do calculus. You're so lucky. We're going to start with limits. That's where calculus starts, is by going to specific values and seeing what's happening at them. I hope a lot of this that we talk about in this video is familiar to you. If it's not, that's okay. I'm gonna pretend like you don't know what's going on, but I hope you do kind of know what's going on, and we'll find out. All right, so we're going to work these questions for this function that is graphed for you on the side, and we're going to start with letters D and E down here, because that's where it makes sense to start. So I want to make sure you remember how to read this notation. This little negative up here means to approach that number from the left-hand side. This little positive up here means to approach that number from the right-hand side. If there's no number up here, like this guy in letter C, it means you have to do both. So let's start with letter D. So we're going to approach 0 from the left. Here's x equals 0. Here's the left of 0. And we're going to go back and approach 0. So it's not asking what is it equal at 0. It's asking as you approach 0. And this curvy-wurvy looks like it's approaching -2. Then I do the same thing for the right. So here's 0 again. If I go to the right of 0 and then start to approach it, it looks like it's going to, yeah, I know it's been a while since you've done math, but these are not the same number. These don't match. Therefore, when we go back up to letter C, if you go straight to 0, approaching it from the left and from the right, and you don't get the same value, you tell me that that limit does not exist. That is the only way a limit does not exist. Limits can equal infinity, and that's okay, or they can approach infinity, I should say. But when limits from the left and the right don't match, then approaching that value straight on does not exist. So let's bounce back up to letter A and just work our way down for the rest of them. We're going to approach 4. There's no left or right marked on that 4, so we have to do both. And it won't always break them down for you that you have to do both. You just have to know to do both. So here is where x equals 4. If I approach from the left and I approach from the right, they're approaching the same value, and they're both going to 8. So that limits 8, and life is good. We'll do it again for -3, which is down here. I approach from the left and from the right. I'm going the same place, and that place is 6. Jumping down to F, which we haven't done yet. This is just practice for function notation. Here's -2. X is -2. Your function at -2. There's so much happening. But remember, you open circles, close circles. This function value at -2 is 8. Even though the limit from the left would be 6, the limit from the right would be 2. The limit at -2 does not exist because the left and right don't match. But there's still a function value there, and that's okay. So there's lots of different mixing and matching of these things. All right, let's go to 2 on the left. So here's 2. X equals 2. This one's the left, so we'll go here, and this guy's approaching 7. They're not asking me to do 2 from the right, but if they did, I would say 0. If they asked me to do x just approaching 2, I would say does not exist because left and right don't match. Right, last question for this guy says -2 on the left. Here's -2. Here's the left of it. Let me squeeze my arrow in here. It's approaching 6. It's approaching 6, even though the function value is not 6. So it's okay that these two things don't match. We will talk about what that means early or middle of next week. But for now, it's okay that they don't match, and that's all fine. All right, I hope a lot of this was familiar. If it's not, shoot me an email, drop a comment in the Ed Puzzle, or stop by for some help and let me know.